Hello, my name is Thomas. I'm working on Openvault, which is a robust Web3 blockchain sort of prototype system that should let you get content verification at a very low cost. So my demo here today is going to be one component of my solution, which is fully implemented and consists of this chain over here. So the idea is going to be that I'm going to have a bunch of nodes, which each have, public private key pair addresses, and they have a connection. They're arranged in a sort of chain, right? So we have nodes A, B, C, and the server you can see here. And the idea is that essentially, instead of A going to the server, we trust all three nodes to record all of their state, hash it, right? And then send it to the blockchain, which is proof of work for various reasons I'll get into in the documentation. For now, I just want to show you that the system works. So I'm on here on the actual development directory. I've got the files here, run.sh, compiles and runs the program, and I have this log over here I'm going to delete. All right. So now, if we go on net.c, I've got it configured here. Sorry, we call it node.c. They're configured to go to cedars.xyz, which is a very simple site. I use it because signing does take a little bit of time, and I want to have a short demo for you today. So here's the whole site. You can see it's relatively simple. I can go over here, inspect the HTML, really small. All right. So we're gonna go over here. We have it configured over here. So what it does is it stubs essentially. It stubs this portion, which is what it will be receiving on the network, right? Plus some metadata. But let's not get into that right now. So what's gonna happen is it's going to send the request. So I've deleted the log over here. You've seen that. So we run.sh. That's going to run the whole program. You can see, right? The whole way pretty quickly. But if we go over here, you can see we have this daisy chain of nodes. Now in the diagram I showed over here, 3 nodes for simplicity. I can configure it to be, a variable amount. In this case, I've gone ahead and done 5. So you can see we're sending them forward and back. Sorry, forward, back, and slowly we end up getting some content here. So what the content you're seeing here is actually from the very first node in the chain, right? So if you look over here, because of TLS, only node A, or in this case it would be node 0, as we'll later see over here in the log, only that node has access to the TLS content, right? So only that node can decrypt all the connection and has access to the keys. So all the actual HTTP content is getting parsed after being returned, right? And now we can go over here in the log and we can see, right, we have the public key. So each one of these nodes, first of all, they publish their public key, right, with their length. In this case, the keys are 1024 bits. And you can see if we go through these, so this first one, node 0 won't actually access the contents. What it's going to register is the public data. And later on, it's going to, later on, in future iterations, it'll post the actual TLS state, right? And it posts the result from that. And then from there on, we have node 1, public key, and we see for every message, right? We'll see the number of bytes sent and received with their hash and then signature. And we can see that node 1, same thing. We see the hash is the same, for example, right? And so on.